In 3+2 machining, only 3 axes are coordinated at any time, and the tool axis remains fixed during machining. It is basically 2.5 and 3 axis operations, but the tool spindle is either rotated, tilted, or both. Click on the part operation and set up the following. For the part body, hide the stock and select the part. Unhide the stock and select it for the stock selection. Click on the bottom right corner on the top of the part and make sure the X direction goes along the longest side of the part. In the machining tab, select 5 axis, and DMS is the preferred tooling, but since the computer does not have it, I will be making my own tools. Lastly, before you press OK, go to the Position tab and change the Z value to 30 inches. Start a facing operation. Show the stock and select the top of the stock for the top plane and the drive. Hide the stock and select the top of the part for the bottom. For macros, select the plane straight above the part for approach, retract, and clearance. Make sure you remember to activate the rest of the steps and copy approach and retract down. For the rest of the information, I followed the instructions in the book. Click on Calculate Toolpath to watch the simulation and analyze it. For the next facing operation, create a new one. Unhide the stock and select the side of the stock for the top plane and drive. Hide the stock to select the slanted side for the bottom. All of the values should be the same from the previous operation. Click on Macro tab for approach, add perpendicular motion to the plane twice. Select the last plane you created from this task and click on the top plane above the part. Next, click on the orange inside the bottom plane and select the slanted plane parallel to the slanted side. Then for retract, click on Add Perpendicular Motion to the plane again, click inside the orange plane and click on the slanted plane. Finally, for the clearance macro, change it from safety plane to plane and click on the slanted plane again. Calculate the tool path and play a simulation. Repeat the previous steps in order to face the rest of the part. Now with the top part faced, we need to do a roughing operation to get rid of the excess stock. Open the roughing operation, select the part for the part in the sensitive area, and make sure the offset is set at 0.05 inches. We want to put a limit contour around the area we want to be rough. Click on the curved line and select the desired area. Once done, you can double click to go back to the operation. I inputted the values from the book for the machining parameter tab. Finally, for the approach and retract, I selected the top plane above the part. Afterwards, calculate the tool path and play the simulation. Open the sweeping function and select the part for the part in the sensitive area. Next, for the limit contour, use the limit line to follow the first curved side. Once done, press OK to go back to the sweeping operation. Then go to the first tab in the operation and click on the tool axis. As you can see, you can click on different areas on and around the part to change the axis. Select the plane that is parallel to the curved area and click the arrow inside the mill to change the direction it faces. Go through the other tabs to make sure the values are correct and that the ball mill is being used. Calculate the tool path and play the simulation. Now start another sweeping operation for the other curved side and repeat the steps I previously did. If you have to change the start direction, go to the Machining Parameter tab and click on the horizontal green arrow. Select the direction that will cause it to run side to side. Press OK and calculate the tool path and play the simulation. Open a pocket operation. Select the top of the part for the top plane and select the bottom of the diamond for the bottom plane. Right-click on the drive to remove all contours. Right-click again to select by boundary of faces and select the bottom of the diamond. For the macros, use Add Perpendicular Motion and select the plane above the part for approach and retract. Copy it down once everything has been activated. Ensure the information is correct for the rest of the tabs before calculating the toolpath. Now we want to drill. Open up a drilling operation, click on the sensitive area, and select the top of the 4 holes. Double-click off the part to go back to the operation. Make sure you change the tool to a drill and use the correct size. The macro commands will be the same as before. Don't forget to activate and copy them down. Calculate the toolpath, play the simulation, and analyze it. Open another pocketing command. Select the slanted side for the top plane and the bottom surface inside the diamond for the bottom plane. Right-click on the drive and remove all contours. Right-click again on the drive and select by boundary of faces, and click on the inside of the diamond. Make sure it is a closed pocket and keep all the islands. Double check the values in the tabs and that you are using the correct size and mill. As for setting up the approach, remember the top plane in the box is paired with the top plane over the part and the bottom plane is paired with the slanted plane. Calculate the toolpath and repeat these steps for the other side. In order to pocket the circles, you're going to have to approach it in the same way, but just remember you need to remove all the islands. The macros will be swinging down just a tad bit in order to machine it properly. In the approach section, the top plane inside the box, select the slanted plane, and the bottom plane, select the plane parallel to the surface below the slanted plane. To change the tool axis, if needed, go to the Machining tab, click on the green arrow, and select plane parallel to the surface being worked on. Once done, calculate the toolpath, and to pocket the rest of the circles, copy and paste the operation you just completed until you have enough, and you can go back in and manually change the sensitive area. Open up Isoparametric, click on the sensitive area and select the rounded corners around the diamond. Double click once done. Then click on the red dot in the sensitive area and find the yellow dots. Click on the top yellow dot until 1 and a 2 appears. Repeat this step for the bottom, but you will see a 3 and a 4 appear. Don't forget to check the radial tab and use the top plane for the macros. Calculate the toolpath. Lastly, I will show you how to do the curved backside of the part. Click on the sensitive area and select the rounded corners. Double click when done. Next step is to click on the red dot in the sensitive area. You first want to click on the inside corner and a 1 will appear. Next, click on the other side for the 2, then go back to the original side for the 3 and click on the bottom corner for 4. Finally, calculate the toolpath. This is the end for the 3+2 tutorial video. Thanks for watching and hope you enjoyed.